Okay, we're solving this problem using completing the square. I like to only use completing the square where it's convenient. You can use them for pretty much any quadratic, but it gets kind of messy after a while. We're going to use that technique on this one, and we're going to first check and see if this happens to be a perfect square. And the trick was this. It's a perfect square if, first of all, we don't want a number out here. We want just 1. That's what we've got. And then if you can take half of this number and square it and get that, then it's a perfect square. Well, with this one it is. -4 is half of that. Square that, you get 16. Okay? And what that means, and we've practiced doing some factoring before, is that you can write this thing really quickly this way, and this number is going to be half of that one. So -4. And you could FOIL this out and make sure that that actually works. So I've used that pattern we've recognized to write this perfect square trinomial as a squared binomial. And the problem is now almost done. All we need to do now is try to peel x out of here, and we'll do that by first square rooting both sides to get rid of the square. Okay, so I square rooted that, got x minus 4. I'll square root 40. Okay. Don't forget that any number has 2 roots, so I'll put plus or minus root 40 there. And then I will add 4 to both sides to get rid of the minus 4, and I get 4 plus or minus root 40. Now I really should check and see if root 40 can be simplified. So I'll step over here and I'll check. 40 does divide by 2 and you get 20, and it divides by 2 and you get 10, and it divides by 2 and you get 5. Using the technique we've used before on this, we know, all right, for every pair of 2's you can take one of those outside the square root sign. So I'm going to put a 2 outside the square root sign. And inside the square root sign, I'll write the leftovers multiplied back together. So 2 times 5 is 10. And then I still have my 4 plus or minus there. And that is the solution to that quadratic equation using completing the square. If you desperately wanted to have a decimal, or if you were told to find a decimal, you would find out what's 4 plus 2 root 10, and find out what's 4 minus 2 root 10, and get your decimals. I'm not going to bother with that. On this one, we're also going to solve by completing the square, but I've noticed a bit of a problem. Half of that squared is not 40. Okay, it's 49. Okay, so half of -14 is -7. Square that, you get 49. So I really wanted the 49 right here. And so I'm going to be kind of bold and just say, well, let's make it 49. Okay. All right, sounds good. As long as I add 9 to both sides, I'm perfectly fine here. I haven't violated any algebraic rules. Okay, well now this thing's a perfect square. I can write it as a squared binomial easily. Let me just find out, see what goes in here. It's going to be half of this number, so -7 okay, equals 50. And I'm well along the way here. I'll square root both sides to get rid of the square. So square root 50. Don't forget, there's 2 square roots, so plus and minus. And then add 7 to both sides, so you get 7 plus or minus root 50. Let's quickly check 50 over here just to make sure that it's, we can simplify it down. You can divide by 2, you get 25. Can't divide by 2, can't divide by 3, but you can divide by 5 and you get 5. Okay, so got a pair of 5's here. That means I can pull a 5 out front here, leave 2 from here, still inside. 7 plus or minus. There is your solution to that quadratic equation using completing the square. And we're going to pause there.